Okay, so good evening to all. We will start today's session with a few examples for the descriptive statistics that we saw in the last session, like median, mode, uh, mean, standard deviation, variance, etc., and quartiles. So that kind of things. We will spend some 30 minutes seeing through the examples of that. So basically in the last session, we saw examples with simple discrete data as well as with group data. Today, for simplicity's sake, I will be covering only discrete set of data, and I will be going through all set of these statistics because group data is just like an extension to our discrete data. So I would like to start first with a simple difference. So what is meant by discrete and what is meant by continuous data? So we will just start with that. Because I think some people might be confused on how to define what is discrete data and what is continuous data, because we will be using this throughout the session today. Even when we go for probability distributions, we will be using these terms discrete and continuous. So discrete data is something that we can always like count. So here by count, I mean that I can count it like 1, 2, 3, or even up to infinity. 1, 2, 3, 4, 5, 6 up to infinity also is like I have like it is called countable concept of countable infinite. So like number of stars in the universe, it is like 1, 2, 3. It is some number, right? It is not infinity. It is some number. So that is like a discrete variable. Or number of students in a class, or number of people who are currently attending this session. All those are discrete. Now suppose we go for the height of all the people in the world, or weight of all the people in the world. So suppose we take weight, somebody can be 40 kg. But when you ask further, is it exactly 40? It can be 40.1 or it can be 40.119. Right, it can take any range of values. So this is like not countably infinite or uncountably infinite. Like it can take between 0 and infinity, and even between that 0 and 1, again it can take infinite values. So that kind of things we cannot like count the total number of data points or total number of values which the data can take in a distribution. So such kind of data, we will tell that the data is continuous. So now we will go to the next first example. So first thing that we saw in the previous session was mean. So mean, as we learned, capital sigma stands for summation. So summation of all the data points. So that is what is take all the values and add them all up. Then what you have to do is you have to divide it by the total number of observations. Divide by the total number of observations. So suppose my data is 1, 5, 7, 9 something and 10. So here I am having how many data points? 1, 2, 3, 4, 5. So here my n is 5. So what I have to do is I have to first take up all these values and add. So 5 plus 1, 6 plus 7, 13 plus 9, 22 plus 10, 32 divided by total number of data points 5. So this will be my mean for this particular set of discrete data. So now there are other things like min, max, etc. So that you can directly infer from this data. So from the data, you can directly see that the minimum value present in this is 1. So that is the minimum in this data set. The maximum value present in the data set is 10. So that will be the maximum. And range is defined as, for a particular data set, is defined as max minus min. Max minus min. So in this case, max is 10, min is 1. So my range will be what? 10 minus 1, that is 9. And the next thing is mode. Mode is like the.
Sorry, I have one question here. Range, I'm talking about, it is 0 to 9 or just 9, the number?
Yeah, range. Range, when we talk about data, range, what we tell is the maximum minus minimum in my data set. So it is not like when we tell normally colloquially when we tell the range, we tell that in the range 0 to 10. Or in Python, if you write a range of 10, that means that it is from 0 to 9. So you don't confuse that range with this range here. This range is applicable for the particular data you are considering, and for that particular data, it is defined as maximum data in the data set minus minimum data in the data set. So it is not like a range like
single number. Okay.
Yeah, it is a single number. So in this case, the range is 9.
Okay.
Then the next thing is mode. So mode is defined as the the value in the data set which is occurring the maximum number of times. If you see in this data set, 1 is occurring 1 time, 5 is occurring 1 time, 7 is occurring 1 time, 9. So each of the 5 data points is occurring only once. So this particular data that we are seeing here is not actually having any mode. But suppose this particular data had like 2 5s in that. Then I have 5, 1, 5, 7, 9, 10 is my data. In that case, I have 2 numbers of 5. In that case, the mode will be 5.
Oh, 5.
Mode will be 5. Whichever data point is like getting repeated the maximum number of times.
It is frequency of the data basically.
Yeah, it is the frequency of data. Whichever data point is having the maximum number of entries, that will be my mode. Now suppose I had one more 1 here, so that my data is 1, 5, 1, 5, 7, 9, 10. So if you see here, you have 2 numbers of 5, 2 numbers of 1s, whereas my other point 7, 9, 10 only 1 are there. So what will be the mode of this data? What do you think? Chat, I need answers. What do you think is the mode of this data?
It is 2 basically, but if we consider only 1, first occurrence will be 1.
Yeah, so what do you think? Is the mode 1 or is the mode 5, or like in the first case that we considered there is no mode? So 3 options I am giving. So which one is the option that you will choose for this particular data? Have 1, 5, 1, 5, 7, 9, 10. What is the mode of this data? Is it 1? Is it 5? Is it none of these? Or is it 1 and 5 both? Chat, some answers?
It is both, I think, but I don't know how it considers.
Yeah. Actually, what you're telling is correct. Actually, the first case that we considered is none of the data is repeated. So in that case, we will say that the data is not having any mode. But suppose some entries are repeated and the frequencies are different, then we will take the entry which is having the maximum frequency as the mode. If some particular value has like in this case 1 is repeated twice, 5 is repeated twice. So in this case, the mode will be 1 as well as 5. So this type of data which will be having 2 modes is something called a bimodal data. The other thing that first case that we considered that having a single mode is called a unimodal data. Now, like this data can have 2 modes, 3 modes, like that. It may depend on the particular data. Now suppose in the same data I have one more one. Then in that case, the mode will again change because now there are 3 entries corresponding to 1, whereas only 2 corresponding to 5. So then this particular data set, the mode will be 1 because it is occurring 3 times.
3, yeah. Whichever is the maximum that we have to consider.
Yeah. The element for which the maximum occurrence is there in this particular data set.
Yeah.
So I hope mean, min, max, range mode is clear for this discrete data, right? You all of you guys can use chat. Okay, Amrit got disconnected. So Amrit, I'll just repeat fast. So I got a data set here. So just assume 1151759. So we are find the statistics, mean, median, mode, etc. for this. So mean, you add up all these elements. So 1 plus 1 plus 5 plus 1 plus 5 plus 7 plus 9. So we added till here 32. So again adding another 7, it will be 39. So considering this full data, my mean will be 39 by total number of data points. In this case, 1, 2, 3, 4, 5, 6, 7, 8. 39 by 8 will be my mean. Then the minimum value in this data set is 1. Maximum value in this data set is 10. So range is defined as max minus min. So my range will be 10 minus 1, 9. The mode will be the data point which is occurring most frequently in this data set, which in this case is 1 since it is occurring 3 times. So now we will proceed to median. So median is what? Median I will tell intuitively. So suppose I have, this is my data. Like I am having some data points here. I am having this thing stands for like 2 minute data USC. Then the concept of median is I have to find a point in this which divides my data exactly into two halves. So I will have one half here and I will have other half here. So the median is basically a data point in the given data which will divide the data into exactly two halves. Now, one thing that you need to take care here is when I am saying two halves, it means that I am considering the data to be sorted either in the ascending order or in the descending order. So that is one precondition before I am trying to segment my data into two halves. So that whenever you are trying to compute median, you always keep that in mind that you have to consider for considering median, you have to take the data either sorted in the ascending order or descending order. Now the second part is you have to find the middle element. So now there are two cases. Suppose I have three elements, 1, 2, 3, and I have four elements, 1, 2, 3, 4. Now if you see for the odd number case, we can know that if we choose 2, then there is one element on the left, one element on the right. So this is almost like dividing the data into two. But then we don't know what we want to do with this two, right? So suppose I consider this two along with this left side, then here two elements, here one element. So my definition of half is gone. And suppose I club 2 with the right element, then left side 1, right side 2, 3. Again, my definition of half is gone. So to avoid confusions like this, there are some conventions like median, which is inclusive of the middle value and exclusive of the middle value. So for all our considerations, we will be considering the exclusive case where once we consider 2 as the median in this case, the left side of the data will be 1 and the right side of the data will be 3. We will be excluding the median when we say the halves. So that is a convention that we are following in our course as well as in my discussion. Whereas in some other standard text and they will be seeing sometimes the inclusive version also sometimes. Both are like equally valid, and depending on your whichever ones you are using, you will have to suitably use the logics that you subsequently should be tuned throughout. So that's the first case. Total number of data points is odd. Now suppose the total number of data points is even. You know that if we divide at this point, the boundary, the middle point, then here I have two elements, here I have two elements. So in this case, I didn't get a value here. Like in that the middle point, I don't have a value here. So what I will do? I will take the mean of the values which are just falling on the two sides of this boundary. So I will take 2 plus 3 by 2. That's 5 by 2, 2.5. So I will divide my data into exactly two halves in case of even number of points. And I will take the mean or average of the 2 points which are falling on either side of this boundary. Is this clear?
Yes, sir. I got it. Yeah.
So I have data, suppose 80, 87, 95, 83, 92. As I told earlier, this data is unsorted. So first step that we have to do is we have to sort its data. So once we sorted, we will get 80, 83, 87, 92, 95. Then I have to divide this data into two parts. Total number of data points is 1, 2, 3, 4, 5 odd. So I will have like divide by this so that I get half here, and this will be my median. Okay. Now suppose there is one more data point in this. Suppose I add one more 98. So in that case, my total number of data points will be even. So in this case, like I told, my boundary will fall here. So I will take the 2 points on either side of that. I will take the average of that. That will give me 89.5. So that way the median is computed.
Average and mean both are same, is it, Arun?
Average and mean are same. Yeah. Average and mean are both are same. When we talk in statistics, we will be like mostly common term used is mean. but it is as same as the average that we are like colloquially talking, or in Excel or something, the function is called like average.
Okay.
So mean and average mean one and the same thing.
Okay.
So okay, so now the second thing that we come into this related to median is what is called quartiles. So quartiles are similar to definition we can define similar to median. So quartile are basically quarter stands for like four numbers. So quartile basically means three data points, 1, 2, 3, which divides my data into four parts. I will have one part here, so like that. This will be my first part. This will be my second part. This will be my third part. This will be my four parts. So basically, quartile is a set of 3 points which are called as first quartile, second quartile, third quartile, which will divide my data into four equal parts. So the same example, both examples, I will see how we can define quartiles also. So I will tell you an easy thing with which you can do. So the first step is you find the median of the data. So median of the data you found here 87, 89.5, that will be your second quartile. So that you find out first, right?
So median will be the second quartile.
Yeah, median will be the second quartile.
Okay.
Because it divides the data into 50% on both sides. So that is your second quartile. Now, how to find the first quartile and third quartile, right? So you go to a definition here. I have divided my data into two parts, left half, right half. Yes. And again here also I have a left part and a right part. Yes. So what you have to just do is you take the left part or the right part, find the median of that again. Okay. So the median of this part will give you Q1 and the median of this part will give you Q3. Okay. Similarly for this data, you take your data into two. The median of this part will give you Q1. The median of this part will give you Q3. Super. So median here is again. Yeah, somebody is having down some doubt.
Yes, 80 plus 83 divided by 2, right? 92 plus 95.
Yeah. Yes. So Q1, I told you to find the median of this point. So median of 80 and 83, since here odd number of points you are taking, you will have to take the average of this. You will again divide by here the points just before and after this 80 and 83. You will have to take average. That will be Q1. Similarly for Q3, you have to find the median of this thing. So 92 and 95 again even number. So you have to divide here the one on left and right. You have to take average of that. That will be Q3. In this set you have three values. So again median you have to divide like here, so that here it will be 50%, here 50%. So 83 will be your Q1. Then for the right part you have to divide here and here, so that this is 50%, this is 50%, and your Q3 will be 95. Is it clear? Yes. Everyone?
Is there any formula for this, Arun?
Yeah, formula is actually simple. If you have odd number of data, it is something like what?
Mid plus 1.
7. Kind of. Yeah, n plus 1 by 2 kind of thing. And if you have even number of data, something like
n by 2.
N by 2 and n by 2 plus 1. So you take data at these two index, add them, divide by 2 for even data, and you take the data at this index for odd data. So because I am not going through formulas and all in detail, because we already covered that in previous session.
Oh, I'm sorry, I missed the last session.
So. It's fine. You can go through the video. Anyway, I'll just going through the examples so that it will be clear, because this is finally that matters when we do. Amrita, any doubts?
Yeah. Let me tell you what I understand. Yeah. So here you have 87, right? 87.
Yeah.
So that is something quartile, something you said, right? Q2, right? This Q2, is Q2. Yeah. So 80 plus 83 divided by 2, that is Q1, right?
Yeah, that is Q1, yes.
And 92 plus 95 divided by 2, that is Q3.
That is Q3, yes.
So this completes here only, no?
Yes.
Did I understand correctly? Or?
Yeah, correctly, exactly, correctly. Similarly, in the second data, 89.5 is Q2. This 83 is Q1 and 95 is Q3. So I hope this part is clear, right?
So in any data, if median, if you find it, that will be Q2 always.
Yeah, it will be the Q2. Q2 will be median always.
Yeah. Okay.
Okay. Now, similar to this, we will define percentiles also, but I am not going through examples for that because that you can go through that. It's like something similar only.
Okay.
And one more next thing that we will see is interquartile range. So interquartile range similar to the earlier range that we saw that we defined as max minus min. So here interquartile range we will define as Q3 minus Q1. Once we find the Q3 and Q1 from the data, you subtract Q1 from Q3. That way you will get the what is called interquartile range. So suppose I have some data here. So first thing, it is not sorted. So first step is to sort that data into ascending order. And second thing is find Q1. So here also I will follow the same way. So my data I will divide here into two parts. So total even numbers. So 60 and 64 I will take average. So that will be my Q2 or median. And then again here odd number of points. So this point will divide it into actually there is an error in this example. Okay, actually there is an error in this example because here the lower, because as you see here, I have divided.
Arun, we can use the previous slide example, that will work.
Yeah, fine.
We can use the previous slide example.
So same, if you go to this example, here my 80 plus 83 by 2, 81.5 was Q1, 92 to 95, 93.5 was Q3. So my Q3 minus Q1 will be 93.5 minus 81.5, which will be 12, right? So 12 is my interquartile range in the first example. The second example, my Q1 is 83, my Q3 is 95, 95 minus 83 is again 12, which is the interquartile range in this example. Okay, the second one I took from some online site. I didn't go through it actually. So I will just tell the answer in there because whatever is shown here is actually wrong. So you divide here 60 plus 64 by 262 is Q2. Then here you have 8 data points. So your half point is here. So 42 plus 57 by 2 is your Q1. And again here you have 8 points. So 66 plus 68 by 2 is your Q3, that is 67. And this will be like 40, this is what, 15, 7.5. So 49.5 is your Q1. So your interquartile range will be not this is actually wrong. I'll correct it when I release this PDF.
17.5.
So yeah, it will be 67 minus 49.5. 17.5 will be my interquartile range. Okay, so I hope this is clear, right? Right, chats, I am not getting much response. I would like everyone to be like interactive in chat as well, so that I can know that okay, you are getting the concepts that we are going through.
You have you covered this? Why you require this quartile? Why you have to calculate in the last video, Arun?
Yeah, that is covered in the last video. You can go through.
Okay.
Yeah. Then next things I will just go through examples. Next thing is mean absolute deviation about mean. So that we saw earlier how to compute mean. So this is similar to once we find out the mean, we want to find out how much deviation we are having from the mean in our data. So for that, the steps that we have to follow is what is this and all we covered in previous session. So I will not go into detail. I just tell how we will compute this. So we have to first find the mean of the data that using the formula that we saw earlier. Then corresponding to for things like this, it is always better to write it in tabular form. So suppose my data is 1, 2, 3. I will first find my mean. So in this case, the mean will be 2. Then in my column, I will have a data like what is x minus x bar. I will write a column like this. So that will be 1 minus 2 minus 1, 2 minus 2 0, 3 minus 2 1. Then the next step is take the absolute value of this. So the absolute value of this I have to take, I have to like ignore the sign. So again here I will get 1, 0, 1. The next step is you have to add all these. So addition of all these you have to add here. It will come as 2. Then you have to divide it by the total number of data points. That is in this case 3. So 2 by 3 will be the mean absolute deviation about mean for this particular data, which contains like 1, 2, 3 sample points. Similarly, we can define mean absolute deviation about median also. So the steps are one and the same, except for the first step, where instead of median, instead of mean, you have to find the median. And in all the subsequent steps, you will that instead of mean, you will use median here, and all the subsequent steps. Other steps are same. So this is how you can compute the mean absolute deviation about mean. Now next thing that we saw in the session was variance. So this part I would like to spend some 5 minutes on this, because actually two concepts are here. One is called population and second one is sample. So similar to discrete and continuous that we saw earlier, these two are is a similar concept that is like confusing to many people. So what do you mean by how can you differentiate between a population and a sample? Telling like I am doing a sample survey on the employees working in a particular company. So in that case, my population will be the total set of employees working in that company, whereas the sample will be the subset of the total employees on whom I am conducting that particular survey. Or if you do some population study and all, suppose you are taking 1,000 people, getting some data from them, that 1,000 people will correspond to the sample, whereas the population for that particular data set will be the entire humans all over the world. Now that is like generic examples. So now when you get a question, you need to find variance and all. You need to identify whether you are supposed to find the population for a variance for a population or for a sample, because as you can see here, there are some subtle difference between the definition of formulas. So you need to identify whether you are supposed to find the variance for a population or a sample. So I will tell you a trick for that. So you look out for the following things in the question: either a sample or sampled or a subset or random. So suppose it will be told like from a class of students, 20 students are chosen at random. So if you get keywords like sample, random, etc. In the question, that means that you are supposed to find the sample variance. Or if you get a word, your question tells you to find a square. So in that case, you can be sure that you are supposed to find the sample variance. Or in case the question tells you like you have to find the population or sigma square, things like that, and nothing is mentioned about sample, random and all, then most of the case it will be like you are supposed to find the this population variance. Now I will give you one task. So I will tell you one question. You have to tell me whether you have to find the population or the sample variance in that case. So we have 4 friends, right? 4 friends who note down their marks for a particular subject, and they want to compute the variance for that. So you tell me whether in that case you will try to compute the population variance or sample variance. Chats, I need answers. We have 4 friends and we are finding the variance of their marks for a particular subject. So which formula would you go for? Population, is it a population or a sample? Yeah.
Sample variance.
Okay, one answer we got sample. Other answers, you can, all of you guys, rather than using the mic, you can use chat itself. I will be monitoring that, so that will be more easier for me also to monitor. Right. So chats, some other answer. Okay, one thing you forgot my pointer. I told like if it is a sample variance, you will get some tags in the question like sample or random, something like that. But here I told like we have 4 friends who write down their marks and they are trying to find the variance. So I didn't mention anything about sample, random or things like that. So this is actually the population here is the 4 friends, because I am not concerned about anybody else, any other student. I am concerned only about the 4 friends. So that is why in this case, the 4 friends want to find their marks and the variance of that, it is actually the population. So now suppose I again slightly modify the question as the same case, I take the marks of 4 students randomly from a class of 40 students. And then for these 4 students marks, I am trying to find variance. Then which is the thing? Whether it is population variance or sample variance, which one I should go for? Right? You got my point? Or do I need to give some other examples to make my point clear? Options, answers in chat, I am not seeing.
One more example, Shirish.
Yeah, actually Arun here. I am logged in as Shirish.
Yes, he is Arun. I am serious.
Yeah.
Oh, I'm sorry.
No worries. No worries.
Okay, no issues. Not able to chat. Shirish, can you just find out? Narendra told like he's not able to chat. So is there some issue with the chat disabled or something like that? You can check. Anyways, I'll give you one more example.
Sure.
Suppose. So basically what we are trying to, this is something very important, because when we go to next class sampling distribution and also same things, we will be like, can somebody try something in the chat to see whether it is working? So basically we will be seeing the concept of population and sample very much. Okay, so if I tell like I have 100 students in a class and I find the marks of all the 100 students, then I am considering what? The full data set, 100 points, all 100 points I am trying to find the statistic for that. So in that case, I will have to compute the population variance. Now suppose I am taking out of this a subset which consists of 10 or 20 or even 99 samples. So out of a class of 100 students, if I am computing, taking the marks of 99 students and trying to find a statistics, in all those cases, I should have to go for sample variance, because I am not considering the full population in my computation. So that forefronts example that you just think like that. In the first thing I just told, like forefronts are sitting and they are trying to find their marks and find the variance. So in that particular problem scenario, we are concerned only about the forefronts. So that is why the population is made up of that forefronts. The second case I told like we have a class, whether there will be more than 4 students obviously. And out of the 4 stars, we are randomly or sampling, that type of words I will use. Choosing 4 students and finding their marks and then have to find the variance. So things like that I have to use the sample variance. So I hope once you solve 2-3 problems, you can get to know the difference. So the difference is very subtle. If it is a population variance, we will denote it as sigma square. If it is sample variance, we will denote it by S square. And if it is the formula is one and the same, xi, that is the particular data value, minus mean divided by total number of samples. Now in case of population, we will use the total number of samples, the total n. That's in case of 100 students, we will use 100 itself. But in case of sample variance, we will subtract 1. So why we subtract 1 here is something which is outside the scope of our discussion, which is a slightly mathematically involved proof. If you are interested, you can go through that. It is basically what is called an unbiased estimate. So to make your sample variance Sample variance is what? Basically an estimate for my population variance, right? Because I have a population, I am taking some samples out of that and I am trying to find the variance of that. So for the sample variance to be an unbiased estimate of my population variance, I am adding subtracting like 1 here. So why that -1 here and all? That is slightly mathematically involved. If you want, we can discuss in that some session when we have particular time, or you can just go through literature that is like very well documented. So here also the things are same. You subtract your mean from the data and you square that, and all data points you submit. So I will just you'll just see an example. So suppose my data is 135. So as we saw in this case, the mean is 3. So sorry, I will go to table form like we did earlier. 135. My mean, let's assume this is the population first. So then my mu is 3. Then I will find my xi minus mu, which will be -1 0. Sorry, 2 -2 0 2. So I think we did mistake last time. It was -2 only. I think okay. Anyway, you can go through. So now we have to what square this particular thing. So that will give me 4 0 4. Then you have to add that. That sigma stands for adding all the elements. So adding 4 plus 0 plus 4 will give me 8. So 8 divided by 3 will be my population variance, considering that this is my entire population. Now suppose this 135 was a sample from a particular data set. Then suppose in that case, let's try to find the sample variance for this case. So in this case, my mu was 3. In this case, my x bar was 3. So this mu is like the thing that is like for the population, entire population, and x bar is like applicable only to the particular data we are considering. So here again the calculation will be same -202. Then again when I am squaring 404, I am summing, I will get 8. But the difference here comes in this n minus 1. So it will be 8 by 3 minus 1. So that will be 4. So I got 8 by 3 as my population variance here. And if I consider that this data is coming from some samples, I get 8 by 2 4 as my sample variance. Now the problem here is suppose you are answering some MCQ kind of questions and all. Most probably both of these will be there in the options. If only one of these is there, then you will be lucky because you can directly find it out. And so most of the cases, if you try it one way, you will get the answer. Don't directly go for the answer. Just check if you are not sure. Just check whether the other thing also is there in the option. If both are there in the options, then as I told, go through the question once again. Try to find out whether you are supposed to find whether you can find some popular pointers like sample, random, things like that from the question, so that you can answer correctly. Because as per whatever questions I have seen, most of the cases both these will be there in the options. Okay. Now once we define variance, next step is standard deviation. So that is what very simple. Either population or a sample, you have to find the square root of this. So this side you take the square root, you get the population standard deviation. You take the square root of this, you get the sample standard deviation. So basically I have just enumerated here. We will not go through examples because the previous example, if you take the root of 4 or root of 8 by 3, you will get standard deviation. So I have just returned just steps for each observation. This is point number 1. For each observation, subtract each observation from the average, then square each difference of that, sum up all the differences, divide sum by total number of observations minus 1 to find the sample standard deviation. And the Greek letter sigma for population standard deviation, as you know, in that case you have to modify this x bar by mu, and n minus 1 you have to replace by capital N. So I hope that is clear. So is this much portion clear? This much portion will be winding the examples for standard deviation or descriptive statistics. So something similar is there for like frequency distribution, order data, group data, thing like that. So that thing, if you want, we can see in a later session. But I think once you get to know how you compute this thing, the other thing is also like more or less straightforward. So shall we proceed to next session? Any doubts in this? Or anything that you would like me to cover once again? Otherwise, we will move to our next part, which is like the most important thing in our entire this subject. Shall we move? Shirish, some issue is there with the chat?
No, I don't see anything, Aaron. All
Can you
seems
type
absolute.
something in the chat? Actually, I am also not seeing nobody is chatting or.
Everyone is chatting.
Okay, fine. I think my. Yeah, okay, fine. Yeah.
Yes, something is actually wrong with Teams. I cannot see participants. Huh? So something is wrong with them. So you cannot see chats and I cannot see participants.
Okay, okay, might be. Okay.
Yeah.
Okay.
Arun, I think there is one topic which we can cover is when to use mean and when to use median. Means what are the complications and what are the disadvantages of using the mean. I think that is something important.
Yeah.
I
Okay.
think, yeah, I think we can cover that because that will actually help everyone out.
Okay. Okay. So we will. I will just give an example of a use case where mean or median you will have some doubts. Right? Which one to use? Suppose my data is 1, 2, 3. In this case, my mean is 2. My median is the middle point, which is again 2. So I don't have any concern with this. Right? So if I take for a data like this, if I take a mean. Ramya, please repeat formula once again. Which formula, Ramya? Standard deviation or variance? Which one?
BEF.
That is before. Okay, might be before.
Achha.
She might have understood now. Might be. Okay. If you have some doubt, you can chat. Okay. I will repeat. No issues. Okay. So basically, for a data like this 1, 2, 3. So this kind of data, what we can tell like this thing is like a perfectly balanced or equally distributed kind of data, where I get my mean and median to be like well poised within the data. I don't have much variation in the value of mean and median, and both reflect actually the central tendency. Like we are trying to find the central tendency of data, right? So where is the point in the data where the majority of points like can be centered around? That is our interest in doing calculating mean, median, mode, and all. So now suppose I have a data like 1, 5, and 25. So mean for my data is what? Let me make it 2 just to make the calculation easier. So 32 by 33. Let's make it 3. So 3, 5, 25. So my mean is 33 by 311 is my mu, and my median is 5. So right. So in this case, which one should I go for? I have a and let's see the range also here. Here the min is 1, max is 3. So my range is 2. And in this case, my range is 25 minus 3. So that is 22 is my range here. So as you can see, when the range is comparable to my data or mean, median, and all, it doesn't matter actually whether I go for a mean or median and all. But to consider the case here, I have got a median of 11, median of 5, mean of 11, and a range of 22. Whereas, and as well, you can see here between 5 and 2, the data difference is 2, and between 5 and 25, the difference is 20, almost 10 times. So this is like an example where I cannot like conclude, because when I take 11, it is like if I draw like this, it will be like towards this. if I represent all these on a number line. And when I take 5, this is this. So I cannot like actually conclude which one needs to be taken here. So then I need to take some decision whether I need to use the median or more. So how I will take that decision? So that will depend on the actual problem statement. Suppose I am telling like this particular numbers are basically the numbers that will come in a particular throw of a dice. So as you can see, when I throw a dice, 1, 2, 3, 4, 6, 5, 6, only 6 numbers can come. So in that case, I can tell that this 25 here might have come here accidentally. So this might not be actually part of the data. So in that case, it is something that we can call as an outlier. So that is, it is not like matching with the actual behavior of the data which I am expecting for the particular problem statement. So when we have a data similar to this, which is having too much outliers, or which is like not particularly distributed or biased towards one end. So suppose I have data like 1, 2, 3, 4, 5, and 4 and 1,000. Then when I go for mean, all these are like small values, whereas I have just a very high value 1,000 here, which will be biasing my, like this thing will be like what, 4, 5, 10, 1,000 and 10 by 5 will be my mean. So which will be like compared to my majority of my data points, this mean will be like too far away. So for things like this, as our initial objective was to find the measures of central tendency. But when we go for median in this case, the median is actually mean. Mean in this case, the mean is actually very off and is near to this 1,000 data point than to all the other data points, majority of the data points in my data set. So for conditions like this, when our data is not like equally distributed or having like some values which are either off by too much or less by too much, or like this outliers and all. So in those situations, as a measure of central tendency, we will choose median. And whereas my data is more or less equally distributed, in those conditions, I'll go for mean. So I think you got some concept, right? So where we will use mean and where you can use median. Clear?
I hope everyone is clear.
Okay. Then we will move to next question.